Good morning, students. In the previous videos, you had seen about the Ohm's law, isn't it? So what is Ohm's law? The current flowing in a circuit is directly proportional to the voltage. So current will be directly proportional to voltage. So if the voltage increases, current increases. If voltage decreases, the current will decrease. So as I said, voltage is directly proportional to current. Actually, current is directly proportional to voltage, but in your textbook it is given voltage directly proportional to current because you have to draw the formula. So because of that, V is equal to I, and in order to remove the proportionality, you have added the proportionality constant, that is R, that is nothing but resistance. So today we'll see what is resistance. So if you see here, voltage is equal to current into resistance, isn't it? So now if I remove the resistance, what do you get? That is voltage upon current. So that is according to the Ohm's law. Now here what happens? We assume that voltage to be constant. Okay, so when we assume the voltage to be constant, what happens? The resistance increases. So when the resistance increases, the current decreases. Okay, when the resistance decreases, current increases. That is when you assume the voltage as constant, that is in resistance. But if you see voltage and the current, it will be same. When the voltage increases, current increases. When the voltage decreases, current decreases. But according to the resistance, when the resistance increases, current decreases, and when the resistance decreases, current increases. So from the word itself, we can make out that it is resistivity. Okay, resistant, it is resisting the flow of electric current. If you see here, so this is the current and this is the resistance. So what resistance is doing? It is resisting the flow of electric current. Okay, that resisting is nothing but stopping the flow of current. Now how is resistance caused? How is resistance caused? Now before that, there is a question. So if you see, this is the conductor. Okay, so my question is, what kind of particles is present inside a conductor? If you see, there are four options: whether atoms are present, electrons are present, impurities, or all of these are present in a conductor. What kind of particles are present inside a conductor? So if you see here, in a conductor, all these particles are present. Atoms, electrons, impurities, all these are present in the conductor. Now my next question is, which one of the particles moves when potential difference is applied across it? Okay, when you apply a potential difference, which one of the particles will move? Is it protons, electrons, impurities, or neutrons? Which are the ones? If you see here in a blue color, isn't it? So those are nothing but electrons. So when potential difference is applied across it, so electrons will move. Okay, electrons will move. So these electrons, they collide with the atoms, impurities, and themselves. These electrons will collide with whom? With atoms, with all the impurities, and also with themselves. If you see here, these are the, imagine these are the electrons. Okay, and these are the atoms, and there are some impurities. So these electrons will collide with these atoms, impurities, and by themselves they collide each other. So what happens? These collision causes them to lose momentum and slow down. That means since they are colliding each other, so they will lose the momentum. And what happens? Since they lose the momentum, they by themselves they slow down. And these collisions are the opposition to the flow of electrons, and this collision is nothing but it is resistance. Resistance is the opposition to the flow of electrons. More collision, more will be the resistance. Okay, when there is more collision, so resistance will be more. When there is less collision, the resistance will be less. Now we know that resistance in a conductor is a result of collision in it, isn't it? The resistance inside the conductor is because of the collision. So let's see the factors which affect the number of collisions. Which are the factors? To change the current in a circuit, consider there is a circuit, okay? So in order to change the current in the circuit without changing the voltage, I'm not changing the voltage, but what I want to change? I want to change the current. So what I have to do? I need to change my resistance, okay? No changing the voltage, but changing the current, and I have to change the resistance. So how can I change the resistance? That is nothing but by changing the factors affecting it, okay? By changing the factors affecting it, by changing the number of collisions in it. So the first factor is the length of the conductor. Now if you consider two water pipes, okay, you consider these two water pipes. One is 10 meter, one is 20 meter. Okay, if you see here, in 10 meter it is less resistance and this is more resistance. Now if you see in both the cases, okay, the first pipe and the second pipe, so water is flowing but only difference in the length. Water flows in a same way. Now if water flows, what happens? There will be friction between the wall and the water, okay, walls of the pipes and the water, there will be friction. Now if you see, if I ask you all, in which pipe has more friction? In which pipe has more friction, whether the 10 meter one or 20 meter one? So you will be able to answer, that is 20 meter one pipe will have more friction. So in case of in conductor, okay, if I take the conductors, for example, you consider these are the two conductors, this is 10 meter, that is 20 meter. So the same things will happen here also, okay. The number of atoms are lesser than if you see the number of atoms, if you consider, it is lesser in second one, not the first one. This is first one, this is second one, okay. 10 meter one first example and the 20 meter one second example. So the number of atoms are lesser in where? In first one than the second one, okay. In first the number of atoms are less. So what happens? Through this we can conclude, as the length increases, collision increases, because electrons will be there, number of atoms will be there, so collision increases. Since collision increases, resistance also increases. So the one of the factor is the length of the conductor, okay. If the length is more, resistance is more, collision also will be more. So therefore resistance is directly proportional to the length. Next we'll move on to the cross sectional area. Cross sectional area. Now if you see the example for cross sectional area, this is a simple pipe, and if you see here, this is a bent pipe, okay. In the center it is bent, isn't it? Now in both the cases, in which resistance will be more, first one or second one? The resistance will be in second one. That is, lesser the area, more the resistance, okay. When the area is less, the resistance will be more. So the same thing if you apply here, conductor, what happens? Obviously you can see in the second one, there is more space for the electrons to move, to flow, isn't it? Whereas in the first case it is less space. So as the cross section increases, the space for electrons, what happens? To move the electrons, it will increase, the space will increase. Since the space increases, what happens? The collision decreases, because they cannot collide with each other, isn't it? Since collision decreases, what happens to the resistance? Even the resistance decreases, okay. So if I increase my area, cross section area, collision decreases, resistance will increases. That is the same thing as I told. As cross section area increases, space for electron increases. So therefore the collision will decrease, so resistance decreases. So what happens here? Resistance is inversely proportional to the area, cross section of area. Now here if you combine both, that is the length and the cross section area, you will get, what happens, you will get R directly proportional to, sorry, inversely proportional to length and cross section area. Now what you have to do, you have to remove this direct proportionality. Okay, so in order to remove proportionality, you have to write the proportionality constant. In order to do equal sign, you have to write proportionality constant, isn't it? So which constant? That is nothing but rho. It is not P, just writing, it is rho, called as rho. So rho is nothing but, it is resistivity. Okay, the constant we call as resistivity. In Greek it is called rho, RHO. So when you write a constant, what happens? R equal to rho into L by A. Now you may be thinking, what is the difference between resistance and resistivity? Isn't it? Resistivity is the resistance offered by a conductor of unit cross section and unit length. Okay, that is the resistivity. So we'll see what exactly the resistivity. Now if you consider a circuit, okay, here what happens? This is like normal copper wire. Now this normal copper wire is connected to a battery. Now my question is this copper wire is made up of atoms, electrons and impurities? Yes, isn't it? Now if yes, will not that wire has something natural resistance? Will this wire will not have a natural resistance? For example, your normal voice. Okay, your normal voice. You have got your normal voice. So similarly, by looking at the natural resistance, we can say which wire it is. Okay, by looking at the natural resistance of the wire, we can say which wire it is. And that natural resistance of wire, or maybe of metal, or maybe of any element, is called resistivity. Okay, resistivity is nothing but the natural resistance of the wire, of the material. Now what if I am teaching, okay, instead of me I'll call one of the students or maybe someone else to teach. So you will definitely find out that this is not me, isn't it? Because what? Because of the voice. So my nature of the voice is different than the other teacher, isn't it? So similarly, resistivity also does not change if you change the length of the wire or maybe the cross sectional area of the wire. If you change this also, but the resistivity of the material will not change. So on what factor resistivity will depend upon? On what factor the resistivity will depend upon? It is nothing but you change the material itself. Until and unless if you do not change the material, that means the resistivity will not change. So you change the material itself, what happens? The resistivity also change. So what is the difference between the resistant and resistivity? Resistance is the overall opposition to the current flowing in a conductor. Okay, it is the opposing the flow of the conductor. But resistivity, what is that? It is the natural resistance of the wire. Resistance depends upon length, area and resistivity of the material, but resistivity only depends upon the material. Okay, this is your third factor, that is nature of the material, resistivity. And the SI unit of resistance is ohm, whereas the resistivity ohm meter. So these are the difference between the resistance and the resistivity. So remember, resistance is the opposition to the flow of current, whereas resistivity is the natural resistance present in the wire, that is the resistivity of the material. The next is fourth factor. Will temperature affect resistance? Yes, students. As temperature increases, what happens? Collision increases. Okay, collision will be more between the atoms electrons. Since collision is more, resistance by itself, what happens? Increases. So remember, the temperature is resistance is directly proportional to temperature. So this is the fourth factor. So what are the four factors? That is length of the conductor, cross sectional area of the conductor, resistivity of the conductor, that is the nature of the material of the conductor, and fourthly the temperature of the conductor. So these are the four factors of the resistance of a conductor depends.